This video will show how to import an STL file of a dog's head and then machine it. So I'm in the 3D cam now, so I'm going to import the STL file. There it is, and I think we probably need to scale this up because it's quite small. I'll just check that my units are in millimeters. You can work in millimeters or inches. Okay, so we go into geometry, scale, and we'll make that 10 times bigger. That's probably about right. If you look at that, that's a 6mm tool, so that's probably about the right size. But if you need to make it bigger, then you can just scale it up or scale it down as you need to. Okay, so we need to create a sketch which will be the boundary for machining. So if we go into geometry, and I'll just draw a rectangle around the shape, and that will act as the boundary. And now I'm just going to set my 0, so I go to milling, set origin, and make the datum point the center in X and Y and the maximum in Z. So now I know that Z0 is going to be the top of the job. Okay, so we probably need to define quite a small tool for that. So let's have that as a slot cutter. If we want to, we can put on an angle on this tool for if it's like a V-bit or something like that. I'll just stick to a small diameter tool, just so it's going to calculate the toolpath. So all I do now is create a surface from that STL file, and I'll check the tolerance. So this is the the tolerance that will be used to create the surface. So you don't want a very small tolerance here. 0.1 is perfect. Okay, so that creates the surface which we can then use. So sketch, right click, make a pocketing operation. I'll set the step over to a large amount to start with. Choose the tool I want to use, and the surface I want it to be draped over. Set the depth, and okay, so that's going to go away and calculate the toolpath for me. You can see that doing that over here. So I've set the step over to quite a large amount, so that I can just test and check that that's going to be machined as we want it to be. Dog head. I'll just save that file away. So that's saving the file away. Now it's going to call up the simulator. Processes the data. So this will just give me a quick look to make sure that it's all doing what I expect it to do. This is the simulator. Accept all the defaults and just press simulate. Okay, so that's the stock material. So we can start machining at the outside, or we can start machining at the centre, and this style of pocketing is following the outside sketch, which is the rectangle. We can also have a zigzag toolpath as well. So okay, let me just replay that. Okay, so that's just given me a quick rough view to make sure that it's doing what I expect it to do. Okay, so if we go back and edit that pocketing operation, a couple of things that we probably need to do is, if you can't machine it all down to the same depth, then you'd need to put in a step down, and you would need to reduce the step over here. But when you do that, it will increase the processing time. So that's now recalculating that surface, and depends on obviously the speed of your computer. If you've got a nice quick iCore 5 or an iCore 7 machine, then it'll do this very quickly. This machine I've got here is quite an old laptop, so it's not fantastically quick. But when you're dealing with these sorts of shapes that can contain hundreds and thousands of vertices, then obviously the more complicated the shape, the longer the processing time. But considering the work that it's doing, it's not taking too long. It just takes less than a minute to do this. Okay, so that's given me a much finer step over now, and now if we simulate that, in effect this is post-processing the cutter location data as though it would be post-processing for your machine tool controller, but rather than producing code for that, is producing it for the NC simulator. So it's actually a good indication of exactly what's actually going to be machined. It is working on the same data that the post-process data will have. Okay, when we come into the simulator, if we don't want to watch the toolpath, then we can go straight to Fastforward, and then that will fast forward through the simulation without showing the tool on the screen, but it gives us a very quick view of what's going to be cut. When we have any simulation, if the tool lead or the length of the flutes are not deep enough to cut that, then it will show it to us in red. So you can easily see that if you're going to be cutting too deep for the particular tool that you've got. Anyway, so that's how we can import the STL file and machine it.